Hi, my name is Shyla Lawrence, and for my demonstration project I have built an electrostatic motor for MAE 535 Design of Electromechanical Systems at North Carolina State University. The construction of the motor was actually really simple. All I have here is a plastic Easter egg resting on a wooden dowel, and it is free to spin, although there is quite a bit of friction. So it's not going to spin at amazing RPMs. It's still pretty amazing to me. It goes pretty fast. I'm sure it could go faster. On my right, I've got some positive charge coming in from my power supply, which I'll describe in just a minute. On the left, I've got the negative coming in, and what happens here is that charge is running up an insulated copper wire onto my copper plate, which I have kind of molded around the shape of the egg. I also have this extra little copper wire probe coming to the back that has just a very small bit of clearance between this copper pad and the egg. And then the the negative side is built the same way. It's coming up a insulated copper wire onto this copper pad. So what makes this thing spin is that the positive charge is deposited onto these copper strips that I have glued onto the egg, and those positive charges are going to be attracted to the negative charges over here on my left. Because the copper is not run continuously around the circumference of the egg, the only way for those charges to get to each other, because they are attracted to each other by Coulomb's law, is as long as the charge is strong enough, they'll be attracted, and the only way I can get there is to spin the egg in order to get there. And I've got this continuous positive charge coming in on the left, so it's going to continue to keep positively charging these strips, and all of those positive charges are going to be attracted to the negative charges on the other side, and it's going to get this thing spinning really fast. So like I said, the construction of the actual motor itself was really easy. One of the issues I ran into was that these things require a tremendous amount of voltage in order to run. I did try a 6-volt and a 9-volt battery to start with, and got absolutely no results whatsoever. I also tried to wire this thing just directly to my 120-volt household outlet, and had no luck that way either. So I had to create my own high voltage power supply. What I have here is a flyback transformer that I pulled out of an old television. It is connected. This is what's directly connected to my electrostatic motor, but the flyback transformer is connected to, on the floor, you can't see it, but I've got a fluorescent light ballast, and that is what is accepting the electricity coming from my household outlet. So the electricity is going to the ballast, and then the ballast is bringing it to my flyback transformer. The flyback transformer is able to take that 120 volts and multiply it tremendously, and from the arcs I was getting before I connected it to my motor here, I'm estimating I'm getting about 10,000 volts out of it.